Hey everybody, this is Chris from Data Minded and Kristof with me as well. I hope you can see and hear us all right. Can you give a shout on the chat if you can? Yes. Hi Frank. Hi Axel. Welcome everybody. We'll wait a few more minutes to get started on this webinar. It's the first time I do Demio as a platform, so I have to figure this out as I go along, but it should be fine. I hope all of you are well, not having too much issues with the new lockdown, sitting at home, trying to figure out how to deal with kids and stuff, if you have kids. Because we are struggling with that. I was just talking to Kristof about that. All right. I propose we get started, right? So people might join in a little bit later. They can catch up. Let me share my screen so we can get started. Yeah, here we go. Yes. All right. So if all is well, you're seeing my screen now. Yeah. So welcome everybody to this new webinar from Data Minded. It's going to be about deploying data workloads in enterprise organizations. And specifically, we're also going to talk about the journey from on-premise to cloud for them. Before we dive into the content, let me quickly introduce myself, and then Kristof will also be helpful if you quickly introduce yourself. So for those of you who don't know us, I'm Chris. I'm the founder and CEO of Data Minded, and Data Minded is a data engineering agency in Leuven. We do consulting mostly. We're at about 20 consultants now. We also offer our own product called Datafy, and we also have a Data Minded Academy where we train the next generation of data engineers, if you will. Kristof, could you also quickly share a bit about yourself?
So I'm Kristof. I am the head of enterprise engagements within Data Minded. So what does this mean? I focus mostly on the bigger clients, the enterprise clients, and help them to build data platforms that are suitable for them.
Exactly. So for everybody in attendance, welcome. If you have a question or remark or whatever, I think in Demio you can put it in the chat. We keep an eye on the chat, so we'll keep track of it there. So why are we doing this webinar? Is because these days it's very easy to get started with data analytics in the cloud. It's creating a cloud account on Azure or on Amazon or on Snowflake or whatever. You click next a few times, you load some data, and you have your analytics up and running. So that's kind of a solved problem. But still, enterprises today are struggling with actually getting up and running in their environment, if you will, following their processes. And we have some experience on this topic. Specifically, Kristof has worked for clients in the banking industry and in the energy industry, like real enterprise, large organizations, and he's going to share a little bit about the challenges that they faced and how we helped them to solve these. Before we dive into the content, I want to do a very quick survey with you. I'm going to put the link on the chat. It should be there now, just to gauge where you are right now with your data platform journey, especially if you're an enterprise. So close the screen, present. So I ask a few basic questions. If you go to that link, you should be able to answer those. So the questions I ask, I just want to understand where you are now. Do you already have modern cloud infrastructure that serves your needs? Do you already apply best practices related to privacy and security? Do you have a mature development workflow set up, self-service for data use cases? Are you able to industrialize data science, data engineering, and data warehousing workloads? And do you have some good standards and best practices for building data products already? So I see the answers coming in. Let's wait a few more minutes or a few more seconds to get more answers in. So yeah. Okay. this is already helpful. So you see that some of you are like in the middle with the cloud infrastructure thing. Some of you have nothing, and some of you are already there. So you're happy with your cloud infrastructure. Security and best practices around security and privacy, that's a spread out, if you will, like you're all over the place. A development workflow, most of you are still struggling with that. Industrializing use cases, that is more or less fine. And good standards and best practices for data products, we're still not that far ahead. Okay, so thank you for that. This helps us because these are the topics these are the topics that we're going to talk about in this webinar, right? So it gives us a good initial impression to see where we are. With that, maybe Kristof, it's useful that you take over the screen. I'll stop sharing, and then you can
yeah
share. There you go. Yeah.
All right, so I'm gonna share this Chrome tab. You can see my screen?
Not yet.
Does it work?
No,
Okay.
I don't see a screen. Okay. If you want, I can share again. I have the presentation here as well, but no, now it's coming. Yeah.
Okay.
Yeah.
So
I see your screen. If you click present, we should be good. Yeah.
All right. So Chris gave the introduction. We have over the year gathered some experience in building data platforms for larger but also smaller organizations. And one of the things that we have clearly seen is that it's not so straightforward. For the bigger the organization is, the more processes that they have, to put, as we call it, those workloads into production. There is a big gap between having something successful running on a cloud account and actually getting the results from that on a daily basis, which are reliable, that you can integrate with your company processes. And it's quite, it's quite difficult to set up because there are quite a lot of things that you have to take into account. The things that...
Oh, I'm sorry, what happened there? Kristof, are you still there? It seems Kristof has lost connection. Apologies for that. While he's coming back, I'll try to get him back into the webinar. While he's coming back, I'll take over the presentation. Apologies for that. I don't know what's going wrong here. Here, can you please join again? All right. All right. Yeah. So as Kristof was saying, there is a big gap between
By the way, I'm back.
Kristof, you're back. Yeah, sorry about that, guys. I don't know, Kristof, maybe I pressed the wrong button or something. I don't know what went wrong, but it's good that you're back. I'll stop sharing again, and then you can take over again.
Yeah, sorry. I'll try again.
Yeah, there you are again. All right.
Okay. All right. So I think there must be something wrong with the Wi-Fi. So, okay. Right. So where was I? I heard you talking about.
Just start over from this slide. We're good.
Okay. All right. Sorry. So there is a big gap between, doing just doing some experiments and actually deploying them to production. There are a lot of aspects that you have to take into account. They are related to the question that Chris asked. It's about infrastructure. What type of compute are you going to use? How are you going to store it? How are you going to integrate with your on-premise data centers? It's about networking. It's about technology. There are a lot of things you have to take into account there. But also security. Companies and enterprise organizations, they put a lot of emphasis on network security and network access. But in the cloud, service access becomes way more important. Then it's also about how to grant users access to services But the very important part is also how do you, in a good way, grant access to data for people to work with on your infrastructure. Another important question is, how do you work on data projects with many people at the same time on many different use cases? Are you going to, what are your CI/CD principles? What is your software development lifecycle, and what is your policy related to that? Are you going to work with multiple environments, dev environment, accept environments, production environment? How will that go? If all of those teams are working together on the same platform, how do you make sure that those teams are not interfering with each other? So it's not so straightforward. So you have to have the right principles in place, because otherwise, yeah, it's very hard to do this correctly. And then there are the typical data science and data engineering aspects you have to take into account. Data scientists want a data science environment. They want to be able to train models. They want to be able to store models. While data engineers, they usually are interested in getting access to data, being able to clean data, build pipelines, take care of scheduling, monitoring, and so forth. So there are a lot of things on how that you have to take into account if you want data engineers and data scientists to work together on a particular project. And also the standardization. When you're a bigger organization, you already have existing processes into place, and it requires that you have to integrate with those. So you have a need for standardization, for templating ways of working, just to make sure that everything is set up correctly. But at the same time, you also don't want to trade because you standardize around certain things. You don't want to lose too much flexibility there as well.
Maybe I can add to this slide. So what we see, like, these are requirements that we see every large enterprise has. And there's two escape routes that they sometimes try to take, if you will. So one escape route is just give every team their own cloud account and let them do all of these cross-cutting concerns on their own. So you'll have many parallel efforts, a lot of waste, and none of the efforts typically result into something. Or the other extreme is like, hey, let's boil the ocean and let's solve all of this at once for everybody in one go. And then they typically spend like 2 years building a data platform before there is a first use case coming out. And that's also not ideal, right? So the challenge for enterprises is to really give teams the speed and the autonomy they need while still serving all of these needs. And that's a hard problem, right? So in the coming slides, we're going to give you some ideas and suggestions about how to solve this, but there's no magic bullet, right? There's no install this tool, click next 5 times and be done with it. It's just a really hard problem to solve. All right.
Yeah. So there are a lot of good reasons for organizations to go to the cloud. And we see that big data use cases are a catalyst for doing things in the cloud, because good reasons for going to the cloud are, of course, yeah, you need a lot of compute and storage, and it's flexible. You just take out your credit card and you can immediately get started. So you don't need to order servers. The servers you don't. They don't need to run at specific capacity. So basically, it allows you to. There are very good reasons why you go to the cloud for specifically big data use cases. There are also less obvious reasons where we see that cloud is being chosen to do big data use cases. And one of the main reasons we see is that there are many business units in lots of organizations that want to go faster than the IT department currently allows in an on-premise infrastructure way of working. And then this causes some shadow IT, you might call, where lots of interesting use cases are being deployed, and they see a lot of value about all of these things. And then this gets a lot of attention from the higher executive management. And this is usually a trigger for starting to think about cloud, because they start to see the benefits that it offers. You can also take it into a change management aspects as well, because if you go to the cloud, things will dramatically change. There are a lot of things that the cloud offers, but there is one thing which is certain, and that one thing is you will do things differently. So if you want to change your processes, then moving to the cloud can be a good reason to do it. But over time, we've been working on quite some cloud projects, but the real reason why you should go to the cloud, it's not the cost of the infrastructure, but it's the speed and agility that it brings. So doing things in the cloud allows you to do things faster, and you have choice about more technologies, and it's easier to set things up. And in the end, infrastructure cost is only a fraction of what the engineering cost is that you need to put use cases out there. So I would really recommend, if you go to the cloud, to do it for this reason. But doing that is not so straightforward. There are many technical reasons why it's not so straightforward. So I would like to focus first on some non-technical reasons. And we have seen over time that when we work on different projects, we have successful projects, we have less successful projects. But we see that the successful projects usually have buy-in from the highest levels of the organization, where the executive committee of the organization really wants to move to the cloud. They really see the value, they really want to go that way. And they also are willing to invest in cloud and data platforms to be able to get the results from that. So it's really important that you have buy-in from the highest level from the organization.
Ask you something about that?
Yeah, sure.
Obviously, I recognize this, but would you say it helps that if you start with a bottom-up approach just to prove a point to get XCOM level of commitment, or how do you typically get that XCOM buy-in? Because that's easy to put on a slide, but it's hard to do in reality, right?
It's easier when it goes top down, but we also know that you have to prove value first. And there have been organizations where it can literally take a year or more before they start seeing the value of cloud. But it really depends on the organization. I think right now the minds have shifted. And I think that most of the organizations are at least considering cloud right now. So I think it's easier at this point in time to start a new project in the cloud than, let's say, 2 or 3 years ago.
And that has really shifted in a couple of years. It's weird. It's weird how fast that is going, actually. Because cloud has been there for 15 years now, but really in the last couple of years, we see almost no resistance anymore to cloud, which is a good thing, right? I mean, finally.
Yeah, that's true. Yeah. Yes, indeed. It took some time, but we're getting there.
Okay.
I mentioned it before, but it's really important. You as an organization need to be able to, you have to be open for change. Things will change. Things will have to be different. Also from ways of working, from processes, from tools, things will change, and you need to involve your whole organization into this exercise, because if you don't involve them from the beginning, you get a lot of resistance, and this can really jeopardize your migration to the cloud if you don't involve everybody from the get-go. Because everything changes, companies also need to realize that they need to be prepared for the new tools and technologies that they're going to be working with in the future. So a lot of tools, services, and it's really recommended if you want to get buy-in from the organization, make sure that these skills get embedded through some kind of training plan or a way of working to get those skills into the people or with the people that need to work with the data platform. If you don't do this, you will get very low adoption, and you will achieve a lot of benefits from your cloud platform. So this is also really important aspect. So now that you've decided to go to the cloud, you know what you want to do, you get buy-in from the highest level. How do you start? We usually recommend to think about if you want to build a data platform for data engineers and data scientists to build and bring cases into production, ask yourself some questions first and try to translate those questions to cloud-based technologies, and don't do it the other way around. Because if you don't ask these questions up front, you will usually end up with an architecture which will serve your needs for a couple of months, and after that, you have to basically start from scratch because it's not usable anymore. So ask yourself from the beginning, how many people do you think are going to work on this data platform? How many teams will work on this data platform? On how many projects will they work at the same time? How important is it to have very fine-grained data access, or is it possible that you just give everybody at least read access to all of the data to work on data pipelines? You also have to think from the beginning about how will I deploy these things? Will I have a development environment, an accept environment, a production environment? How am the CI/CD principles, software lifecycle? And also a very important one is, because we see a lot of organizations have a dev, accept, and production environment, but as long as you don't have good data in development or accept, it actually means that everybody will just do your development in production. So you have to think about these kinds of things up front before you can actually start thinking about a design or way of working for clouds. And of course, you also have to make a very important decision. Am I going to go for a data lake or a data warehouse way of working? So where you have to take into account, lots of things there. I'm not going to get into the details here, but this is an example on how choices you make over here can have an impact on, for example, an AWS cloud strategy, or whether you're going to use AWS managed services, or are you going to build your own data platform. I think the bigger the organization, the more requirements that the organization have, the bigger the needs that you have a data platform. The goals of a data platform, they can be very broad, but at least they should offer the following things, which are, they should enable for data scientists and data engineers to bring their own use cases in a self-service kind of way without too many, you can't always avoid it, interference, that they can bring it to production themselves, that they're end-to-end responsible for it, and that they can do that and have the tools to be able to do that. Data access and governing the structure of your data in your data lake, your data warehouse, that is also something that the data platforms need to play an important role on. And of course, the data platform should help to bring the right data engineering patterns, how to build and train models, and how to bring those models into production. So the data platform team should be able to focus on those things.
Maybe I just want to emphasize what you say here, that we recently did like a lot of interviews at an enterprise organization, and it turned out that their main bottlenecks were not like, hey, my model training is not going fast enough, or my Spark big data cluster is not scaling big enough. It was really these points. It was many team dependencies, many handovers. It took weeks or months to get something done that actually in coding time takes a couple of days. So these aspects, if you're unfamiliar with this, they sound boring and trivial, if you will, but if we're in the middle of this, so if you're working on enterprise data platforms, I hope this resonates with that is sometimes very hard to solve.
Okay, so this was hopefully more the high level part. So I'm gonna go a little bit deeper right now. So I'm gonna focus mostly on an AWS platform and AWS principles, but most of those principles also apply for Azure and Google Cloud if you are considering or working on those. But it's always nice to know some things up front when you start building data platforms. And we've done this a couple of times, and we've learned a lot over the years, and I hope to share some of those learnings with you that hopefully can lead to some practical choices. So how I look at AWS and all the other cloud providers, Azure and GCP as well, I consider them as Lego blocks. Lego is awesome. AWS is awesome. They have lots of managed services. Half the internet runs on services like S3, EC2. And if those services go down, you will see a real impact on the internet. But the thing that it really happens not a lot or not at all, it really shows that these services are really strong, that they're really good, and they should, and we really recommend to use them. But all of those services are usually very low level. I consider them like Lego bricks, Lego blocks. You can do a lot of things with them. They're very detailed, fine-grained. They all have their specific purpose, and they fit very nicely on top of each other. But in the end, every organization, every enterprise is different. And if you want to build a data platform which is suited to your needs, yeah, there is a lot of there is a big step from going to all of these Lego bricks to have a data platform in place where your data scientists and data engineers can actually start working. And building the good data platform, not too complex, but with the right capabilities, starting from those bricks without a manual, yeah, that's not so straightforward.
Kristof, I have a question for you. There are also these, let's say, integrated solutions on the market that promise to just do everything in one system, and you don't need to know the underlying cloud technologies. How do you look at those integrated all-in-one solutions?
Are you talking about the ones offered by the cloud services themselves, or?
No, typically, so one concrete example is for instance Cloudera, where they say if you just do everything in Cloudera, everything will work nicely together.
Well, I don't believe that there is one tool that can do everything. I'm a strong proponent of using the right tool for the right purpose. And yeah, Cloudera is good at one thing. It's good. It's kind of a platform that tries to cover all of the things as well. But for example, Cloudera is a different beast because you have to make a conscious choice. Or you step into the Cloudera ecosystem, or you step into the AWS ecosystem. And when you go to the Cloudera ecosystem, you basically bet against the cloud might not be the right word because everything works into the cloud, but there are a lot of managed services from AWS, from service providers that are really useful, but they integrate really badly with Cloudera. I'll give an example. If you want to use Cloudera for data access, you have to use Ranger, for example, and Atlas. If you want to use AWS services, you have to use AWS IAM, and those are completely orthogonal on top of each other. So it's not so straightforward to mix and match AWS services and Cloudera services.
Okay.
Does that answer your question, Chris?
Yeah, it makes sense. Thank you.
Okay. So I mentioned it before. When you go to AWS, you really have to consider what your account strategy is going to be for the clouds, for big data use cases. AWS has this concept of account, and what is an account? It offers a clear separation between resources in one account cannot access the resources from another account. And this makes a lot of sense when you think about I'm a web service, I'm a web team, I run an API, and these things communicate with each other through APIs. There it makes a lot of sense that every team has its own account. But when you're doing big data use cases, which has a lot of shared services, shared data, where your goal is that many people work together on the same data sources, this account strategy of it's not so straightforward. And also, when you think about accounts and you want to use managed service from AWS, when you want to configure them, you need to be able to set IAM permissions and security groups, which is firewalling concepts. And this basically gives you admin permissions on top of your account. And if you're working with 50 or 100 data engineers and data scientists on the same platform, you don't want to give everybody admin permissions, because yeah, I can guarantee you that things will go wrong. So on the other hand, you might say,
yeah, sorry to interrupt. Just from their point of view, they also don't want admin privilege. They just want to do their job, right? They don't want to figure out all these low-level AWS things. So it's from both sides. It's not very helpful if you just give admin to everyone.
Yeah. So, and it's also because of that reason, across account, you might say, okay, then give every team their own accounts. But then, yeah, cost will explode. Security can no longer be guaranteed, and it's very tedious to set up cross-account data access between, if you want to share data between different teams. And also, Chris mentioned it, AWS is very detailed. It has a lot of low-level things you need to know just for it to set up correctly. And I don't think that this is the right level that data engineers and data scientists should work on. But it's important to know and decide up front, for what strategy do I go? Because, or you go for a multi-account strategy or go for a single account strategy. Yeah, these changes have a big impact from the beginning, and you need to make a conscious choice there. Also, networking, because this is about big data and big data use cases. It's very important that once you set up your network in the cloud, that you set this up as if it was some kind of a virtual network or a virtual extension from your local on-premise data center, if you have this. Why? Because you need to be able to ingest data coming from systems which are running operationally probably in your on-premise data center, if you have that. So you need to have network access to that. Another thing that we really recommend is people and organizations fear going to the cloud because they think, I'm going to put my data on the internet. I don't want that my data is available for everybody to access. And I would like to point out that this is absolutely not the case. It is up to you to decide what level of security that you want to put on top of your data. But AWS offers you all the tools you need just to guarantee that the data you're working with is local to your private networks and not beyond that. So this is something you need to know. AWS is very secure and it has a very good security model, but it's up to you to decide on how to configure it. So you need to know that. Something you also should know, and this can literally save you months of development time, is that AWS services, they require access to the AWS APIs. But by default, you don't have that. So if your network does not have access to the internet or does not use VPC endpoints, you can start an EC2 instance, but you will not have access to AWS services, so they will not even work. So it's very important that you realize this. And if you want your AWS services to work within your own private networks, you need to at least have this. You should not have HTTP proxies in there, and you should not have HTTP intercept enabled, because if you start doing that, AWS services don't know these two concepts, and yeah, they will simply not work. So save yourself a lot of time before start going to the cloud. Really take a look at these kinds of things. Also, internet access. There are a couple of principles that many organizations, every access to the internet needs to be whitelisted, but that usually can lead to a lot of overhead just to get, and complexity just to get something working, because it needs to be approved and it takes quite a lot of time. But there are also other principles I would like to put some attention to. It's kind of a trust but verify principle, where you allow relatively broad access to the internet for people to use. But at the same time, keep a very close watch on what is happening And when something seems to be an anomaly, that you can immediately intervene and react if that is necessary. So if you want to go faster, go for a trust but verify principle. If you're really security minded and you really fear the malicious attacks from within the organization, then the whitelisting approach is probably very relevant. Okay, automation. Because building a data platform and building data pipelines reliably is not so straightforward. There are a lot of complexities that need to be taken into account. I can make one recommendation, and that recommendation is automate all of the things, everything. The moment you start introducing manual tasks, this means that mistakes will happen, and it might seem faster at the beginning that you're doing some manual task and not automating everything, but this will really bite. This will really have some effect later on down the line, because the more things you have to do manually, the more errors will happen, the slower it will be to put things into production. So I really recommend everybody automate everything, and the tools are there to do it.
And maybe that's one of these other things that is very easy to put on slide, but very hard to do in practice. Indeed, the tools are there, right? So there's plenty of choose your own CI/CD tool, take a modern one that scales and is flexible. But the tools are out there, but still we see a lot of organizations struggling with actually getting this done.
You also have to take into account, multiple environments. If you have a development except in a production environment, you need to be able to have some automation in place, or otherwise you're doing it 3 times. So it's very important. Chris mentioned it, have a good CI/CD tool that does the building and the testing and development, the deployment part, that does your deployments automatically for you. All right, so something else which is quite important, we feel definitely for data platforms and definitely for larger organizations, is data access. How do you grant data engineers and data scientists access to data? So in most of the bigger organizations, what happens? Users, data scientists, data engineers, they want to work on a project, they want to work with data. What happens? They request access to a specific data source, and they ask this to the different owners of the data source, and then these will approve them. But they usually have no idea, these data owners, where is my data going to be used for? What is the type of purpose or project that is going to be for? So it's not so straightforward. So also when 3 people are working together in the same team, they all need to request the data access to the data source 3 times. So mistakes are easily made. A lot of requests are coming to the data owners. They don't want to be the blocking factor. So they will just approve blindly because they don't want to be the bottleneck. And if you are a data engineer and a data scientist working quite some time within the organization, you basically get access to all of the data. And then you see that some organizations start putting extra governance checks into place just to make sure that the access to the data is being used for the right purpose. And then you know that this model is come to its limits. And it's for that reason that in some organizations, we recommend to go for a purpose-based access control mechanism or project-based access control mechanism, which basically splits up this whole approval process into 2 steps. So first you have a purpose or a project. Companies decide to work on something. You can link this to GDPR procedures like DPIA, so it's an impact assessment for data use cases. Once these things get approved, you can ask for a particular purpose access to specific data sources. The data owners, they understand my data is going to be used for this particular purpose, and they can consciously make the decision, all right, this is approved or this is not approved. They get way less requests, and they have a better overview about what data is being assigned to what purpose. And it's also easier to revoke access because you know what the impact is going to be, and the impact will only be on this particular purpose or project. On the other hand, you have the data scientists and data engineers, and they will request a specific role to work on that particular purpose. So you might have a data engineer role and a data scientist role, and they will give the right data access and service access at the same time for the data engineers and data scientists. So it makes it very user-friendly for the data engineers and data scientists to start working with this way of working, with this approach, because I'll give an example. A data scientist can get immediate access to a data science environment where all the data access is being set correctly out of the box if they're working on a particular purpose. So they don't have to think about it anymore. As you can imagine, we're just scratching the surface here. So I mentioned GDPR legislation, DPIAs, right to be forgotten. Yeah, a lot of things you have to consider. The bigger the organization, the more sensitive the data. Yeah, the more important that this all becomes. And yeah, going into all of these aspects will definitely lead us too far. Of course, monitoring, metadata management, we did not discuss this as well, but it's also a very important aspect when you build data lakes, when you have a lot of data in your accounts and that you want to use within the organization. Having good metadata management is really important. And also very important is data quality. It's better from where I look at it to have no models or than bad models which are trained on bad data. So the garbage in, garbage out principle is very important here as well. Okay, so this sounds all very hard, right? So this means that this will always have to take several months to multiple years to bring your first use cases into production. So we're here to show that this is actually not the case. So if you do this correctly, if you take the right approach, if you make the right investment and give it the right focus, you can, in a very short amount of time, achieve quite a lot. So I'm going to present you the case of Luminous. We'll be working together with Luminous to build to help them build their data platform to bring data science use cases into production in the organization. So we started about 6 months ago with the implementation of the data platform. And the situation back then was that they have a lot of experiments that they have been working on in different cloud accounts. So sometimes they use AWS, sometimes they use Azure. And they see a lot of the value that it brings for the data science use cases that they have. But they started to understand we can't keep on working like this because data is in Azure, sometimes it's in AWS. Many teams are using the same data sources, so they have to ingest the data multiple times, so there is not a lot of reuse. Also, the operational costs were getting quite high. And so the organization understood it was necessary to have a good data platform to build our new use cases on. And initially, before they started, and it's very important, they also did a study. And during that study phase, they got support from all the layers within the organization to take part in this endeavor. And without this, this would definitely not have been a success. So fast forward 3 months later, Luminous was able to set up good landing zone setup with integration with the data centers of the on-premise data centers that Luminous currently have. Where you have network access so that we can access the data sources which are stored within the on-premise data center. We also had Datafy up and running completely. Chris will dive into that a little bit deeper. And we could immediately start ingesting our first data sources from the on-prem data center, and we also started doing that. Once those ingestion jobs were done, we also started working on a pilot use case. Our first use case, which was our test to see whether the platform could actually do what it promises. And also important, within Luminous, they decided to roll out a training plan to educate all of their current data scientists and data engineers and business analysts about what's changing, what are the technologies that they need to work with. And what we really see is that also because of that training plan, we get a lot of traction, we get a lot of interest. People start to see the benefit of these technologies and tools, and a lot of people within the organization are very positive about this, and they can't wait on building their new data cases on the new platform. So again, fast forward to the situation today. We have almost our first use case completely up and running in production, almost. We have the data platform in place, which allows you to do organized data access, takes care of all the security, scheduling, computes, monitoring, how to deploy things, experimentation environments, development acceptance, production. All of these things have been taken into account into a single data platform. And I mentioned it before, we see a widespread adoption of this platform already within the organization because we did our first use case, but also three teams are currently working in parallel on multiple use cases at the same time. So how were we able to achieve this? They were able to, Luminous spent the time thinking about what the good operating model would be for them. And they decided to go for the following approach, where they have a landing zone team, which is responsible for creating the AWS accounts, distributing them to the teams, making sure that the networking is in place and that the security and monitoring aspects are taken care of. And then they provide these accounts to the data platform team. And the data platform team will set up a data platform and will take care of all the data platform related aspects, like deployment strategies, purpose-based access control, offer a data science environment, offer templates, and so forth to allow the use cases teams to get started and building their use cases on top of the data platform. The use cases teams, they are self-service teams, and they are responsible for everything related to the data product. So it's about data ingestion, using the data which is ingesting on top of the platform, deploying those use cases to production. So they're responsible for everything themselves. And the data platform supports them in a way that they can focus on what's important to them. So they don't need to care about infrastructure and scaling and security and these kinds of things, but they just need to write the right code. They're responsible end-to-end for the code that they write, scheduling and all these kinds of things. And the data platform takes away the heavy lifting. And this allows that the use cases teams can very quickly build use cases and put them into production. So Chris, you take the floor. I can't hear you, Chris, so you're probably muted.
Classic mistake, and I keep on doing it. Like at least once a week or twice a week, people need to remind me on but so yeah, I just have one more slide to add to this, just to a deep dive on the product that we built, and that's part of the data platform at Luminous, is Datafy. And what does Datafy do? It enables data organizations to industrialize their data products at scale. So just as a general concept, all larger enterprises, they all have many use cases like data science, batch streaming, data warehousing, whatnot. And they all have several platforms to deploy on. So they could use SageMaker, they could use Databricks. They might want to run everything on a Kubernetes cluster. They might want to deploy their data warehousing jobs to SQL. Where does Datafy fit into this picture? Where did we try to position ourselves as well? Actually, for all the use cases, we provide you templates, and companies can make their own templates so that you can follow best practices, have paved roads for each of these use cases, so you don't have to reinvent the wheel all the time. And we also make it easy to deploy your use cases to each of these platforms, right? Where by default, we deploy to Kubernetes because that's our, let's say, our native environment to deploy on, but it's very easy to deploy to other environments as well. And then we try to take away as much of the, let's say, boring cross-cutting concerns as possible. So we try to do as much monitoring, cost control, scheduling, role-based access control, all the data security that Kristof talked about, the project overview, so that you and your team can focus on building the use cases and making sure they run on the platforms that you want them to run on, and we take care of the, let's say, more the boring, nitty-gritty details in the middle. So the impact of that is that it reduces operational complexity because it's serverless, so you don't have to worry about scaling. It's a fully managed service that runs on Kubernetes. It runs in your cloud, automatically scales up and down. It's also governed because we implement and enforce the security best practices, like what Kristof said, the purpose-based access control is enforced when you deploy projects on through Datafy. It's also fully self-service, so you don't need to have a central team that runs this for you. Every data team can get started with Datafy. It's a very powerful tool to have. At the same time, it keeps all your run options open. So it's cloud native. In the end, you build Docker containers that you can schedule on the Kubernetes cluster. But as I said, you can schedule on anything you want. And it uses a lot of open source technology. So you're free to deploy them where you want, how you want them. And also, Vincent, I'm going to come back to your question that you asked a lot earlier. What about multi-cloud? One, don't underestimate the complexity of multi-cloud. I think it's a reality for large enterprises that you have some workloads on one cloud and some in others. But having the notion of I can transparently deploy from cloud to cloud is not easy. But that is one of the things that we are working on with Datafy, because if it runs on a Kubernetes cluster on Azure, it should also run on a Kubernetes cluster on AWS, right? I'm not claiming this is free or cheap in terms of time, if you will, but it's definitely possible if you standardize on common technologies which are available across clouds, that you can achieve this, right? So if you're interested in this, definitely get in touch to know more. I see some more questions popping in. At the same time, I have a survey for you. So if you go back to mentimeter.com, I have to go to the next slide at Mentimeter. I'm going to ask you the next question. So I ask you like, hey, it's the same question as before again, but then rate yourself in terms of maturity and importance. Like, where are you in your journey for cloud infrastructure, for security and privacy, for enabling multiple teams, for enabling multiple use cases, and for standardization? So these are the topics that Kristof talked about. Rate yourself on the maturity scale, like where are you? And also in terms of importance. And why we ask this is, of course, because this helps us understand you're obviously our target audience to hopefully do many projects together in the future. So this helps us understand where you are in your journey. While you're filling this out, I am, and you find the link in the chat. I'll post the link again, maybe for those of you who don't find it. Let me double check. Yeah, here it is again. I'm going to copy paste the link again. Here it is, just a sec. Boom. Here's the link. So I see some people are, one person has filled it out already. At the same time, Kristof, let's go over the questions. So some ask, the data platform suits modern strategic and self-service data analytics, aka BI. Does it also serve, and on which layer do you suggest operational embedded analytics? No, definitely some. It's a very good question. Kristof, maybe you want to add to this as well. The line between analytics and operations is blurring, right? So the time where you had your operational applications, you just throw everything over the wall to your analytics environment and then have some BI reporting on that, that is done, right? It might still be there, but that is like less and less important. Actually, analytics today, when we talk about industrializing use cases, we're really talking about putting it in an operational flow. So it might be a recommendation engine that you deploy to your website. It might be a churn prediction algorithm on which you base an email campaign. There might be many use cases, but having them as part of an operational system is actually really important in being successful. Steven asks, concerning new implementations like this one at Luminous, which challenges do you get to get everyone involved? Which challenges do you get to get everyone involved on the same page? And how, Kristof, that's a good one for you. How did you get everybody involved? Because that is indeed hard. Yeah.
First of all, buy-in at the highest level. I think if you get marching orders from your from the XCOM level of your organization, this makes things really a lot easier. But at the same time, within an organization, there is sometimes some politics. There are some other sensitivities that you have to take into account. And we, as also external people, we don't know all of them. But our approach is, as I would like to call, radical transparency. So we show exactly what we're going to build, how we're going to build. We're going to propose it to them. We proactively try to go to the people who are involved with it. So we talk to the infrastructure people, to the security people, to the there are quite some there is also some architects that we need to involve. So our idea is that we proactively try to find all of those stakeholders, interact with them, and try to get their buy-in, and so that they understand the benefit that it brings. I must say that that this approach got a lot of positive remarks at Luminous.
It's as important, if not more important, than your technology choices, right? If you can do whatever you want, if you don't have company buy-in or team buy-in, and you'll never get there 100%, but you should get a very long way there in order to really have impact on your organization. Because the risk is, if you do this without buy-in, you're just playing around on an island on IT somewhere, and nobody cares about that. It's a very clear risk. Rafael asks, like, hey, to what extent is Datafy addressing data permission management, if applicable, and data exploration? Check which data is available within the organization. So what we do with Datafy is the purpose-based access control that Kristof explained. We offer tooling for you to set that up and to enforce that. We are not trying to replicate Collibra or whatever other data governance tool that you might have, right? So if you want to find out which data is available in an organization, you need a tool like Collibra or a Munson or any of these tools. Once you know where the data is, the same actually with the process, like how you get access to data. Is it through a data owner? Is it through the chief data officer? Is it through the data privacy officer? Like that process is best managed in a data governance tool. But then the technical enforcement and definition of these roles and permissions, that is something that we can do in Datafy, right? So we really try to complement the governance tools out there.
Yeah, and what we also try to do is provide a good user experience to the data scientists and data engineers, so that things work out of the box. So what I mean with that, I mentioned it before, you have a data science environment which is linked to a specific purpose. You can just click on it. If you have the right permissions to work on that project, you will get your data science environment. All data access will be automatically set up correctly. So this is how we as Datafy can help to improve the user experience there.
All right, I'm trying to be conscious of time and respectful of your time as well. So like with that being said, I hope this was helpful for you. I hope we kind of showed high level how we approach this for large organizations. If you want to know more, Kristof is heading all our enterprise engagements, so he's probably the best person to talk to, but also feel free to reach out to me if you want to talk to me. If you first want to read up a bit on what we're doing, we have a blog on medium.com, and we also have a channel on YouTube, which I'm sure you can't remember all that crazy characters there, but if you search for Data Minded on YouTube, you'll find us, and you can look at previous webinars. Also, make sure I'll try to get this downloaded from Demio and get it uploaded on YouTube as well. And with that, I think we can wrap up the session. And if there are no further questions, I hope to see you next time. All right, Kristof, thank you very much for your contributions and guiding us through this webinar.
You're welcome.
All right, thank you, everybody. Take care.
Have a nice day. Bye-bye.
Bye.